All right. Well, it is 6:15, so probably a good time to go ahead and kick it off. So welcome to Modern Dev Charlotte Meetup. What we do, right, is bring together developers to learn about technologies across a wide, to learn about tech from a wide variety, right, a wide breadth of technologies. So what I'd like to do is introduce our sponsor, Tech Systems, who is normally providing us wonderful food. And so they've stuck with us for years and years and years, even through a pandemic, this one. So thank you. Jenny, did you want to go ahead and say a few words?
Yeah, absolutely. Thanks for having us. Sorry that all we have to contribute is my voice today and no food. Hopefully this time, I know last month we had some people from out of state joining, so hopefully we have some non-local people also being able to join hear David speak today. But like Doug mentioned, I work with Tech Systems as a recruiter. I also have my partner Emily Richard on the Microsoft team Meetup as well, and she focuses within .NET development recruiting. We both focus in the software engineering space. And I know it is tough times right now. So if anyone is interested or may have anybody in their network that is looking for jobs, luckily companies are still hiring and there are positions still moving. So we'd love to help anybody that we can. I'm going to leave our emails and our contact information in the meeting chat. Definitely feel free to connect with us on LinkedIn or send us over a personal message. But I know you guys are in for a treat today with David, and I hope you guys enjoy it. And thanks for continuing to stay up to date with us.
Great, thank you. It's so weird that there's no clapping at all. So thank you. And so without further ado, I'd like to introduce David Wilson. So David and I have known each other a long time. We worked together at LendingTree for over 5 years. During that time, he was my team lead at one point. And he's currently a staff engineer there. And today he is going to regale us with .NET Core and Raspberry Pi combined together. So if I should probably stop sharing, right? So I will stop sharing and you can kick it off, David.
All right. You should see my screen very soon, if not already.
Yep, I see it.
All right.
Yeah, it was good.
Turn on slide share. All right, my name is David Wilson, as Doug said. I've been working with LendingTree for a number of years, and I decided that I wanted to try out the Raspberry Pi and everything it had to offer because it was Christmas time, so it was a good opportunity to get one. And they had just recently released the Raspberry Pi 4. And one of my eventual plans is to start putting a little small site on it and see how it does. So I decided before I did all the work to do that, I should probably see if I can even get it running with .NET Core and see what's involved with that, how hard is it, and also how does it perform? Because it's not a laptop, it's not a PC, it's not even a server really, it's a little computer. So with that in mind, I thought I would share what I've learned and also how easy it was to get up and running and to get .NET Core on it. I will not be showing how to assemble it, nor will I be showing how to do a headless setup. I thought that a headless setup, meaning there's no monitor, no keyboard, and I plug it directly into the laptop, I thought that would be a little too impactful for a internet presentation when I would have to be adjusting my laptop's settings to do a direct connection, changing the network. So a little too risky for that. But I will show overall what I did and also install .NET on it and play around with the console commands and do some performance testing, show you the results of that, and given time, we can go into more things as we progress through. Feel free to ask questions. Doug, I don't know if you can moderate that. when I'm presenting, I'm going to lose being able to view the chat. So if somebody has something, Doug, if you could just interject and I will answer.
Yeah, sure. I will definitely monitor the chat. If people have questions, are you good with them unmuting and asking?
I'm good with that.
Okay. All right.
All right, Rod, looks like he's having audio problems, but I assume he's the only person. I assume others can hear fine. All right, so what is a Raspberry Pi? I'll show it on my screen. There you go, that's a Raspberry Pi. However, the Raspberry Pi is just a small computer. It has a Broadcom chip on it. The 4, they upped the CPU version and the amount that it could do on it. It's still 64-bit versus the 3. I believe the 3 was also a quad core, but they did increase the speed and make some other changes. In particular, they changed how much memory comes on it. I'll go to my next slide. Sorry. There we go. Here's the 3. I'll try to go back and forth so you can see some differences. So you'll notice that this 3 that I've got here presenting was a quad core also, but only 1 gig of RAM. Now with the 4, they have 1, 2, and 4 gigs of RAM soldered onto the board. I went ahead and got the 4 gig because I wanted performance. I didn't want to deal with anything slower than the maximum I could get. So I do not know the differences between the 1, 2, and 4 as far as how it performs, other than I got the 4. Excuse me. It does have a gigabit Ethernet, and the Wi-Fi offers the 2.4 gigahertz and the 5 gigahertz. If you care to use it for your actual, with the monitors, you can actually hook it up to 2 displays. I did not test that out. I'm mostly just running it as a little mini server, so I do not have any big screens on it. I did steal a small screen I have. All right. So compared to the 3, the 4 is a big jump. What kind of computer does that make it? Does it make it like my laptop, my work laptop, my old personal laptop that I have next to me? Or does it make it something even better? Not quite. It is not a sports car. It is not an aerial atom. It will not blow your socks off. But it is actually surprisingly well. It's more like a little sports car, or little car that tries to pretend to be a sports car. This is a Honda Civic, in case anybody wanted to know, CRX. It's sporty, but it's not a real sports car. The parts that you need for running a Raspberry Pi is, of course, you got to buy one. Mine was from a location on Amazon, just a little starter kit. They run, depending on when you buy them, $60, $80, and depending on how many parts you want already on it. I got one with the little power button and some heat sinks and the whole starter kit because I decided I would just start from scratch. There's also a Cana kit, that's what I got, but a few more parts on it. You notice that they're not really much money. That's a good thing. Back one. You will also need a SD card. Some of them will come with one, others will not. I went ahead and purchased a 32 gig Samsung, but you need the small one, the micro SD. You can get up to 64. I actually, first one I did was a 64, worked out just fine. I just had to format it differently. I'll give you a little brief overview on that when we get there. Depending on how you set it up, you'll need a networking cable or you'll just need access to your Wi-Fi. When I originally set this up, I did a headless setup, I called it, because I didn't have a monitor, I didn't have a keyboard or a mouse. I just had my laptop and a spare networking cable. And I did set it up successfully, no issues. It was surprisingly easy. Like I said earlier, I will not be presenting that, but I do have instructions for that if anybody's interested in setting up that way. That will be in my GitHub link that we'll send out later. you should be able to follow along if you like. If you have any questions, of course, I will try to answer questions later on. However, for this presentation, I am going to assume that I've already done most of the setup and I've got it hooked up to Wi-Fi, and we will just remote into it. But the typical computer setup is quite easy, and I will give instructions for that. Excuse me. Any questions so far? No, I will continue then. Like I said earlier, assembling it's really pretty easy. I will not show that because I just didn't think it would go well on a presentation. Downloading it, the OS is, I did the typical easy setup. I just went to raspberrypi.org, download their latest and greatest, and the size is going to be 435 meg to 2.5 gig, depending on which version you pick, and additional options you choose on there. Like if you want to run the whole GUI and all that, of course, it's going to be bigger and more things to install on it. To prepare your SD card, you're going to need, of course, an adapter if your laptop or personal computer does not have support for the micro. You'll need a little adapter. See if this comes out well. But most of them come with that. At least the two that I purchased had an adapter with them. But be mindful when you buy them that it may or may not have the adapter. All right, so after you download it, you're going to want to extract the OS from the zip file. You're going to extract it, and then you're going to burn it onto your SD card. Sorry, my 19-year-old cat is joining us. Now, I will just give a brief presentation on this. Unfortunately, I had to exit full screen because the video would not play. I used a tool called Baleen Etcher. After I unzipped the OS, I unzipped it, and then I ran Baleen Etcher. It was actually very easy to get up and running. After you format the SD card, I did 32. I just left the default because I got a 32 gig and ran it. It was real quick to format. And then the process of burning it was also delightfully easy. As you can see here, I just selected the image that I unzipped, and then I started the process. Now, the process of burning it took, I would say, about 2 minutes or so, which I will not use up all this time here for that. But as you can see, it just started, and then, of course, Windows wanted to ask permissions to do that. I told it, yes, go ahead. All right, let me go back into full screen mode now. All right. Now, once you burn your SD card, the image onto that, of course, like I said earlier, you will have to decide whether you have a keyboard and monitor and things like that you have spare. Depending if you do, that'll choose how you will set it up. I have, like I said earlier, I will have a link to the headless setup if you choose to do it without any of that. There are some tricks to it, but it was actually fairly easy. Losing my video, but this little SD card, you just slip into the bottom. Just reattach it. And then I am only going to plug this into my power cable. I'm just going to put it next to me and turn it on. Now, unfortunately, I will not be able to present the initial setup of the configuration. When the Pi first boots up, you will have to do a little bit of configuration, like getting on your Wi-Fi if you want it to do that. It'll ask you to change your password, the Pi password. The default is username is Pi, password is Rasberry. For the presentation, I just left it as is. These are the instructions to go through that. The one thing that you will want to do, most likely, is to turn on SSH. So you can remote into it at will from your personal laptop or your personal computer. And that's what I'll be doing here, is I'll just be remoting into this Pi sitting next to me.
So given that I see sudo, I'm assuming, okay, it's Linux, but like what kind of operating system is it? Is it a specific subtype of Linux, or can you run Debian on it, or what?
You can actually run Ubuntu on it. I did not try that, but I did read several articles of that you could do it. Actually, I believe the most recent version of Ubuntu, they may have a specific instruction set out there for it. I do not have that up, but the version, the Raspbian, actually, let's go to it. Let's go back. Thank you for asking, Doug. Let's go here. Please give it a second while my computer brings it up. All right, it is based off the Debian, and excuse my pronunciation if I pronounce it wrong. And Debian Buster is what this one's based off of. It's a trimmed down version. It doesn't have everything that if you install Ubuntu on your personal laptop or anything like that, you'll find that it has a lot more things that it has to offer. It also has more package management systems. The package management system of Raspbian is familiar to my using of Ubuntu, but it is different. Some of the packages that you would be able to install, let's say on Ubuntu, you won't be able to install natively on Raspberry. You'll have to fall back to either the pre-compiled libraries, or you'll have to download the source code and compile it yourself using hopefully instructions that they provided. Any more questions?
No, nope, just curious, and I know you were moving on, and had moved on, really, but when I saw the sudo, it reminded me.
Oh, yes, gotcha. And like I said, I had downloaded, oops, can't use that button. I had downloaded the Raspbian Buster, which the version I got was 417, I believe. Let's go back. Nope, 419. 419 is what I'm running, which is the same. They must have changed a minor version here. So the kernel is the same, but the release date is different from when I originally downloaded. Any questions in chat before I continue on? No questions in chat. Perfectly fine. Now, does anybody have, I'll call out, does anybody have any questions about assembling the Pi? I know I didn't go any into that, so I do want to give the opportunity if anybody has any questions about the hardware, plugging things in or anything like that, or whatnot.
Yeah, and I know last month when we did this, right, a lot of people didn't have mics. So Marty is asking, do you run with heat sinks?
I do. The kit I bought has it. Do I need it? I honestly don't know, but the kit I bought, it has it. They were very easy, little stickers. You just peel off sticker, put it on. I have not bothered to run any analysis on the temperatures that it's running, but I've also not had it crash on me, so that is good. I'm definitely not overheating it, making it crash for those reasons. Even during my performance testing that I was doing, I actually had put a lot of load on it originally when I was doing my performance testing, because I had a nice little bug in my code that I had written. I basically had a very tight for loop that never ended. So it was cranking out max CPU for many hours and did not experience any problems other than my performance test never ended. All right. I do not see any other questions. Doug, is everyone unmuted?
I believe so. If not, people are able to unmute.
All right, I will continue on then. Now, what I consider the fun stuff. Let's get to .NET Core on the Raspberry Pi. Now, unfortunately, you have to do a manual install. I had read that .NET Core was you could just install it with the DB. Sorry, I'm forgetting the extension, but the package manager, DEB, I believe it is. I thought I'd just be able to download and run off of that. I did try. I got a nice little error message, and that's what made me say, okay, can't do that. I will go and fall back to the manual install. Please excuse my cat. All right, so instructions to do that. It was actually also, even though I couldn't do the package management install, it was still fairly easy. Some prerequisites have to be installed. Sorry, where'd my presentation go? There it is. So you have to just get the latest updates and then install a few additional libraries. I'm just going to show a little recording of me doing this because I wanted to make sure that I did not use up all my internet to download these things. Simple, type it in. Overall time it took to download these libraries, it was like a minute, 2 minutes at most. Sudo apt-get update, and then install these specific commands, or sorry, libraries. Sorry. Let's zoom forward. And it downloads them, installs them just fine. I will go to the next slide. Same thing. This is where it gets interesting. What you need to do is you can either take from these locations I've got here that are available on the slide and also on the GitHub location that we shared later, or you can go to Microsoft's site. I just did .NET. .NET. Come on. Download Linux. Since I originally downloaded, they've had newer ones. Like I said, the package manager will not work, but what you can do is you can take the locations that it mentions in here for whatever version you're trying to download. You can actually download 2.0 and run with that.
Marty was asking, did you use sudo apt-get upgrade? And I saw you used update. I'm not familiar with upgrade.
Correct. I did update. I probably could have done upgrade, but I didn't want to do a upgrade everything on my Pi at that time. That's what I believe upgrade would do. It would just upgrade everything that it's already pre-installed and upgrade everything to the latest. I didn't want to do that, so I just did update, which let it download, if I'm correct, and just download the packages available. And then I told it to specifically, I want to install these additional libraries. Where's my mouse? Sorry, I am just trying to quickly find the location of the files, which I am not able to do right now. It's ARM 64. Yep, ARM. Tell you what, I will update the instructions on that because it looks like it moved on me. But you can at least take these if you like and download them and install them that way. But I will tell you there's been at least 2 versions released since then, because this was 3.1.100. I believe it's on .300 now. Download time, of course, will vary depending on yours, but we'll just skip ahead. Download the first one, then download the second one. First one I downloaded is the SDK. The next one is the runtime. Depending on how familiar you are, SDK is what you need to compile and some of the additional tools, but in particular compiling. And then the runtime is self-explanatory, I believe. It's to run said libraries later on. Could I have done just one or the other? I definitely needed the SDK to be able to compile locally. Now, I could also use my laptop to develop on, publish the libraries targeting Linux ARM, and then just run the libraries over here using the runtime, which I did do initially. And if there's time, I can show how to do that. Finally is extracting the libraries. Now I'm going to remote into my Pi that I've had up and running for a while now. So I'm going to bring up my terminal. And we are going to attempt to remote into it. Now my IP addresses have been changing lately, so I'm just going to scan my local network real quick. Oh, looks like it's still 27. All right. Now, as you can see, I have not changed my password. It's giving me a nice little warning. But as everyone should, you should change it after you've done your initial setup. But I knew I wanted to keep it the same for this presentation, and I will change it later. Now, this is a base install. The only thing I've got here is a backup, just in case I lost connections or needed to drastically revert and get back my previous installs of dotnet. So I will copy. Let me go into backup. I'm just going to bring down the zip files, not zips, I'm sorry, the gzip files. Copy start.gz, but you can pretend I downloaded them for you over my Wi-Fi, which is what I did the other day. There we go. Not as fast as you might experience on a SSHD hard drive, but not bad. So to unzip them, we would just do tar zxvf is my favorite one. And I'm just going to put it into home.net, which is going to be right here next to these existing files. Paste. Let's try that again. Nope. All right, fine. Next. I am just typing it again in case there is a hidden character. Nope. That is not working for me right now. So this is why I have the backup.
It's always inevitable, and it
Yep.
has to happen at least once, right?
I did it twice last night. No problems. All right.
Marty mentioned gunzip might work, but yeah, if you've got it.
Yeah, gunzip may work, but I didn't have to do it last night. The tar command worked actually several times, but be it as may. Last night and before, I just unzipped the SDK and then unzipped the tar file, and I put them in the same location, same base directory of .NET. I could have done separate, but putting them in the same did not cause any issues, and I saw instructions that was acceptable. All right. Oops. Sorry, kitty. All right. So next, more goodness is set the home, set .NET root, set path, and run .NET info. Now I actually did do this last night, .NET info. It's already set. I'll echo my path. You can see over here, I've got home.net, which is where I unzipped it to. And then .NET -- info, just to make sure things are up and running just fine. And look at that. That is all the steps you need to run .NET on a Pi. Any questions before we actually run a little program? Put a dash. Oh, you know what? That's right. The dash is probably what was missing. When I copied it over to PowerPoint, it probably lost that. Yep. That is correct. Thank you, Marty. Marty pointed out that I was missing the dash in front of these, which was lost. I was copying and pasting. All right. Anybody have any questions? Any concerns? All right, I will continue on to what I consider the fun stuff. Let's just bring up a simple little hello world. I'm going to use Microsoft's .NET's just little templates. Hello world. Go into hello world, .NET new console. And the reason I'm doing this is because I want to show you how reactive this is. It is a small computer, but it's not painfully slow. It's actually, I was quite pleased on the speed of it. I knew it was a quad core, but it's still not an Intel or an AMD or anything else like a Snapdragon or anything like that. So I was concerned originally, but after playing around with it, I was quite surprised that even simple development and not so simple was still quite, trying to think of the word. I wouldn't say performant, but it was reacting well. Like I wasn't sitting at the computer a long time and waiting for the commands to come back to me when I type them. Build, and I'm going to do without the -R that I'm showing here with -R Linux ARM because it should work without it. Later on, some applications that we run, like the web API, when I ran that, I started getting issues running it. But the -R targets the Linux libraries. That was the build and run. So you notice the build took 7 seconds, just over 7 seconds, and the run, I wasn't counting, but it felt about 7 seconds. This is the error that I was getting the other day. So let's do .NET build -R Linux, R not F, Linux -ARM. So now it's just going to quickly recompile it. This one is taking a little bit longer. Probably going to be about 10 seconds, 15 seconds, 13.48. Now we're going to do .NET run, same thing, -R Linux ARM. And we should get the hello world from the default console application. There it is.
So I missed it anyway. Marty asked, wondering if VS Code will work with Raspbian. So did you just text edit this, or did you already have the doc completed, the text doc?
This was Microsoft's
Okay.
template. So what I did was just .NET new console. We'll get into some other ones later, but this is, you can do this from your computer and it'll just spit out. Let's see what it spit out. A program CS and a CS project file. Let's go into it since you're asking. We'll use VI. And Marty, the question or the answer is yes, you can get VS Code running on a Raspberry Pi. I did it, I'd say about a month ago. But you could not use the package management. You have to either try to figure it out on your own or find someone that's already done it. Scott Hanselman recently posted an article on his blog with instructions on it. Someone has already created a script that will install it for you. I used a little bit older version. I did not add that to the presentation. I did experience an issue with that originally when I did it, so I did not want to include it and have it blow up for me. So I decided to keep this simple and not use VS Code. That being said, I did use Visual Studio on my work laptop, created several applications, and I copied the files over, and then I also did publishing, and that worked fine too. A little bit slower, of course, to do development on a laptop, copy the files over, or publish and copy those over. Excuse me. And you can get VS Code running. Like I said, here is the hello world that the .NET console application, .NET New, created for me. Just small, simple. There's several options. I'll just open that later. So shows you, yes, you can get a small little thing running with .NET's new templates. Sorry, let me go back to presentation mode so we can celebrate. There we go, we celebrate, we got it up and running with a simple application. Now, what if we want to do a nice little website? Microsoft and those developers have already created similar things. So just like we did console, we can do a web app, and in a little bit we'll do web API. Same thing, is going to spit out a small, simple little program that you can just test out and get up and running. I actually use this quite often on my own at work when we get the latest from Microsoft. You know, they publish 3.1, soon they're going to publish 5 probably. I will tend to do a .NET New after I install the next version, look at the project files, see what's changed. So not only do I do this on the Raspberry Pi, but it's also useful in normal work to see what I need to do for an upgrade. So this .NET New, I would suggest if you haven't played with it, play with it later on and get familiar with it, because it does help out normal development scenarios. Now I'm in presentation mode again, so I cannot see comments. So if you could just shout at me if you have anything, I will answer. Excuse me. So next, we're just going to do a small little website using the .NET New command. So make directory hello world website. And I typed it wrong, excuse me. And tab is your friend, in case you haven't noticed. I am hitting tab to autocomplete. .NET New .NET New web app. And just like before, it's going to create some files, just using a little template it's got. You see here, we've got more. We've got app settings, JSON, development, program CS. We've got a www root and startup. Now, just one thing to note is the templates that it spits out. API properties. Launch settings. It will run the application on localhost, listening on HTTPS port 5001 and HTTP port 5000. Now, if you want to run this code, but also hit it from your from your laptop or any other machines in your network, you will need to change this to listen on either the specific IP address that you're running or cheat, take the easy way out and just do star. Like this. Cut word, star, hit the wrong key. Move the cat out of the way. Save that, exit. And now when I run it, I will be able to hit it from my laptop, which I will show you after I build it. .NET build, same commands, no changes there. Linux -arm. It will take a little bit longer to compile, but not much longer.
Richard asks, do you need to install a virtual environment to debug the code for ARM on Windows?
You mean to be able to do like remote debugging? Or some other way?
Yeah, I mean, I'm kind of hoping, Richard, that you respond there. I took it that way as remote debugging for ARM processors, right?
I did not try that. Would be a good exercise to try. Instead, when I had debugging, I just cheated since I was doing fairly small apps and I wasn't doing anything really specific on Raspberry. Like I wasn't trying to access any of the these pins or anything like that. Sorry, I can't show it on the screen. I've got it plugged in now, short cable. But if I was trying to access those things, which I don't have on my laptop, I probably would have had to do some debugging when I had problems. But instead, same applications I was testing with, I could run on the laptop as I could run on the Pi. So when I had a problem, I just debugged on my laptop. I could have set up remote debugging, but I did not.
Okay, and then he asks a follow-up question, which is, what's the drawback to writing code on Windows and deploying to the Pi? Which it sounds like is totally what the way to go, right? I mean, that's what it sounds like from the way you're explaining it. But
well, the drawback is time, because you get it working on your laptop and then you need to get it over to the Pi to actually start working. Now, if you mess something up in the copy or you happen to hit a snag that maybe it just doesn't work the same way it does on your laptop, then you're going to be back to saying, well, it worked over here, why is it not working over there? Those are the drawbacks that I experienced. Now, thankfully, when I did experience problems where it was working on my laptop, but it wasn't working on the Pi, they ended up being simple things like, I didn't alter the but the IP address that the application was listening on. Simple things like that. But if I was still running VS Code, it would have been much easier to do that on the Pi. However, like I may have mentioned earlier, most of my initial playing that I did with my Raspberry Pi, I originally did a headless setup because I didn't have access to an extra monitor, extra keyboard, or mouse. So I actually spent quite a bit of time just remoting in and working off that. So I didn't have the luxury of having a UI. Probably could have done some work to allow me to access the GUI remotely, but I just didn't feel that was worth my time.
I have a kind of general question, which is basically like everything I've seen around the Raspberry Pi is about, putting a website on it, right? But there would be other use cases, right? I could imagine, like at least like listening to a service bus or something, right? Like, have you, I guess here's the question. Given what you've seen, what other use cases are you seeing besides putting a website on it? A web service, really.
Other than the typical Internet of Things or putting Pi-hole on it, I haven't thought of any other uses personally for me to play with .NET on it, other than I do want to run a website or two on it. We actually we volunteer with the local Greyhound group, and our plan is to rewrite that and put it onto the Pi, and maybe something later on. But the group is spending several $100s a year when I know I can get a Pi and just run it on that just fine, because the usage on it is not going to be overly burdensome for a Pi.
Okay, gotcha. And I did see a cameo from one of your Greyhounds. So cool.
Yep. So yes, there are other reasons to run .NET on it. Just I personally, the only thing I want to do right now is just run a website or two and keep my investment small. That was really my main objective. Is like, I could go get a rack mount computer that's probably $200 and stick it in the closet and let it be loud and run it just fine. But I don't want to spend $200, and I don't want to waste that much space for just a website that is not going to be making me money. It's going to be kind of a personal thing. That being said, you could probably run some nice sites and use your imagination and run some fairly several I'll leave it generic things on it without any issues. The performance test I'll show will hopefully prove that to you, that it's actually not a sports car like I was showing earlier, but it does quite well. So let's go to my browser. And I am on, I believe it was 128. Yeah, let's try 128. I've already forgotten my IP address. Hello World website. Not 30 because my router gave me a new one. 28. And let me double check my IP address, because it may have been something different. Scan. 27. I was wrong, not 28. 27. There we go. So once I did the correct IP address, it actually came up quite quickly. Bouncing around, it's a simple site, of course. It's only got 2 little pages on it. It's reacting quite well. Let's go back. No errors over here, always good. Over here, I talked about playing with SSL. If you want to hit the site without SSL, you will have to turn off the redirect. So I'll show you what I mean here. So I'm going to try to hit it without HTTPS. Notice it's HTTP over port 5000, and I get redirected pretty quickly to 5001. And that's just the default security that Microsoft has thankfully coded for us, just to help us developers out, to make sure we're always have our site at least a little bit more secure. And if you need to or want to turn that off, it's just very simple. Edit the startup file. Don't do this in production, of course. You just go down here and remove the HTTPS redirection, and then you'd be running locally. Now, if you really want to do it in production, you would also turn this off. But again, you don't want to do that in production. All right, so that's a plain old website. What about an API? Oops, too many keys. So before I get to the API, I'm reminded to go talk about the .NET New a little bit more. .NET New -- help. I believe, Doug, you were asking earlier about how I created the little shell program earlier, and I was talking about this .NET New. If you want to play around with it, like I was suggesting, just do help. And let me do help, pipe it into less, so we see everything. There we go. You'll see there's all sorts of templates. I got plain old class library, WPF. I did not play with those. Worker services, again, did not play with that. I've mostly just used API, web app, and console applications, but it will support most of these other ones. I would think there may be a few that you could have issues with, but again, I haven't tried it, so there's no proof of that. I would like to start playing with that one, but I did not have time to do that. Any questions before I continue on? Oh yes, Marty, of course I could have done ifconfig, but I didn't want to cancel my application that I was running earlier because I was fairly close on my guess for the IP address. All right, so web API project. And the reason I wanted to bring this up is to start talking about performance. How does Raspberry Pi do as far as performance? Oops, I was doing these applications in my .NET folder. I did not mean to do that. I'm just going to move these real quick. Out of my .NET install directory. There we go, nice and clean. All right, let's make a new directory called Web API Performance Test. Again, just using the nice little .NET new command. All right. Now I'm going to do the same editing I did earlier for the launch settings. And this is that way I can run web surge from my work laptop. Nope, not that one. Host with star. There we go. I just replaced all the local hosts with star. And because I'm going to do a performance test, I want to alleviate any issues that I know web surge. Web surge needs to be able to hit either a robots text file or this web surge dash allow text. That's just that way you don't accidentally run web surge against CNN or your own production website that you have running on your servers by accident, which I'm sure someone probably did. All right, so let's edit the startup file. API startup. Time check 7:09. Let's see. I'll use tabs because they are better. Right, Doug?
I mean, Silicon Valley taught me it's 4 times more efficient, or 8 times, 4 times or 8 times more efficient.
Something much better, much fewer. All right, let's see. And I need to create the web surge allow file. Oh, gotta make the www root. Make their www root. And then cd touch to create the file, web surge. -allow.txt. If I don't do this, WebSurge will complain. All right. .NET build. Go ahead and type the -r Linux -arm. .NET build. Nope. Run. Notice it's taking a little bit longer to compile. And this is another reason why getting it working on your stronger, more powerful laptop may be beneficial. Sorry, that was my dog. .NET run -r Linux -arm. Get the site up and running. While that's coming, we'll bring up WebSurge and my browser. Let's go make sure that this is up. WebSurge -allow.txt. Make sure it really return an empty file. Yep, 200 response, empty document. Excellent. Now, with WebSurge, what we're going to do is we're just going to hit this weather forecast. Location 27, which is just going to spin out some predefined weather stats values. I'll show you that controller real quick. I'll stop the application running. Just show you controllers. Again, all this was generated by Microsoft's.new command. Weather. Notice here it's got some predefined values, and it's just going to do some random values for over here to spit out the temperature, things like that. All right, let's get out of that. So it's not exactly static values, but some static, some random mixed in. So not real world, but good enough to test with. Get that up and running again. All right, make sure it's still running. All right, now let's run WebSurge. And we're not going to run a series here. I just want to show you the tool WebSurge, just to show you how I did some testing. Right now it's over Wi-Fi, and my laptop is also on Wi-Fi, so not as fast as, let's say, if I had it plugged in. But let's do 10 seconds, 5 threads. All these are turned off, by the way. And I'm just going to start the load test. 27,500. Let's see, did I type something wrong?
Yeah, 5001. Right.
Yep.
So you typed 5,000. It looked like.
Should still be up and running. There we go. That is. And yep, 5,000 weather forecast. Let's type WebSurge. WebSurge allow and run this again. Start. WebSurge -allow.
WebSurge has the wrong port. WebSurge has 5,000 instead of 5,001.
Oh, I forgot to turn off the redirect. Let's cancel that. And the reason I wanted to do that is because I wanted to test without the computation of SSL earlier. So let's go do that. I'll be bad and turn this off. Let's get up and running. Pi. There we go. Did not change the port on me. This should work this time. Run. Right down here is 35 requests, 2 seconds, 918. There we go. It is putting a little bit of load on the system. Now I'm going to open up another terminal, just in case anybody's curious, to see how the CPUs are reacting to this. All right. You could use top or HTOP or any other tool you like. I like the colors. So let's run it again. Oh, by the way, before we run it, you see it manages to do 284 requests per second for a total of, round up, 2,800, 900. I like rounding. So 2,800 rounding down. Max response time, 56 milliseconds. So we'll run it again. And on the left, if you watch the CPUs, we'll see how it likes to load. Look at that, more than one CPU is getting the load. So without any changes, we are seeing Microsoft's .NET code spreading the load across the multiple CPUs automatically for us without us having to do any custom code. And that's just, I just want to mention that because it's a nice thing to see that you wrote this code possibly on your Windows machine or your Linux machine, and it's using all the cores, and proof putting on a Raspberry Pi that has 4 cores available, it's also doing the same. Now it won't do it as well, but it still does it. So .NET Core is reacting the same way as I would expect. Now just bump it up just to 20 and let's do 15 threads. Actually, I'm going to do 60 seconds. CPUs are working a little bit harder. There are more threads that we are sending to it from my laptop. Again, I am using up resources right now by showing HTOP and also using up resources on my laptop. So if I plugged things in and wasn't doing a presentation, we would actually get higher numbers that I'm going to show you now. But when we get to the next screen, you'll see the results of when I had the machines, both the Pi and the laptop plugged in using physical cables, of course. All right, time is 48 seconds. We are almost done. I'll just let this finish. Notice it's still pounding the CPUs, not fully, which means I could throw more load at it, but I do not want to do that right now with a presentation. So we went from, 200 requests per second now to 850 by increasing the threads, and the total requests also jumped up nicely. The max response time did go up, but that's to be expected.
So John Dye asked, would you get any benefit of throwing Nginx in front of this on the Pi, or would that just make the load worse? My guess would be worse, but yeah.
Yeah, that would be my guess. I did not try that. I will note that Microsoft's documentation shows that Kestrel is it's meant to be on the edge nowadays. When .NET first came out, they were proposing or suggesting that you always have Nginx in front of it. The documentation, I think in 2.1, could have been 2, is when it changed to say, you know what, you could put Kestrel up front. So ever since then, that's what I've been doing.
I think that was all a security concern as well, with them
There
like
was
not
that too.
offloading right, but not being the stop for certificates and stuff like that. I think it always made it a little slower to have the Nginx in front. It just gave you more features, including right security.
Mhm. Yes. All right. Let me close out of this. All right, back to the slides, unless anybody has questions. Cancel out of that. All right, so here is the results when I ran the same application from my laptop that I'm presenting on right here last night. I reran these results. It changes a lot. So take these numbers with a grain of salt, because when I ran it again a week before, the numbers were, I'd say on the same scale, but they always changed. And that's normal no matter where you run your things. If you only run it one time, you get the results one way, and then you run it again, you'll get results hopefully similar. But very different numbers, because it all depends on what's going on, either your network, your computer, the client machine. And I wasn't doing extensive testing. So there'd be ramp up time depending on how much time I ran and things like that. So again, take these numbers just as a good indicator of how things perform on the Pi. First example right here is 5 threads, 10 seconds. I think when I ran it here when presenting, it was 280, and last night it was 373 requests per second. And I just ran a total of 5 tests. As you can see here, the more time I allowed it to go, the better, the more requests per second I was able to take. And also the more threads I threw at it, the more requests per second it could handle. Now, at some point, I got to a tipping point. I jumped up from 15 to 30 here, and hit the key. 15 to 50 threads, and I started experiencing degrading results. I started getting some failures, but look at the requests per second. 2,500 requests per second. The website that I was talking about, that we want to just put on the Raspberry Pi, this gave me full confidence that the Raspberry Pi would be able to handle the little bit of load that those site or sites will be experiencing. Here I did 100 threads for 120 seconds, 2 minutes, and I got even more requests per second. No failed results, but you can see, actually that was a typo there. Ignore that, 111 seconds. That was a typo. Here you'll see that the time is 8 seconds. And that's what I was trying to elaborate here, was the degraded experience was greatly increased for max response. All right. Next was, how does that compare against, a laptop or a personal computer that is, honestly much bigger, much more powerful than a Raspberry Pi. So here we go, is this laptop that I'm presenting on is a, okay, sorry folks. Just a second. All right, there we go. Personal laptop.
Going to see keyboard cat? Is keyboard cat coming on?
Yeah, she's going to keep coming up and down. She's our 19-year-old cat, so she gets to do pretty much whatever she wants because, hey, she's 19. The performance results, as you can see, for the local host testing on my laptop, 5 threads, 10 seconds, big difference. I mean, 4,000 requests compared to 373. Let's look at the test number 5, 1,100 threads, 120 seconds. It was handling close to 4,000 requests per second, nearly 500,000 total requests with a max of 55 milliseconds. That is quite a bit of difference here on the max response time. Total requests is actually fairly close. Again, I will note here that different runs will experience different results because I am not doing a true benchmark test. These are, I would call them spot testing. Any questions?
So your 15 threads, right? So this is on your laptop on localhost. Is that what that is? 80,000 requests per second.
Mm-hmm.
And nothing else came even in that order of magnitude, right? I mean, that happens to be the sweet spot, apparently.
Yeah. Well, I did. There is quite a bit of jump here. Notice this is 15 threads for 60 seconds. This was 50 threads for 120 seconds. So there's probably a better area in here. I was wanted to limit my time that I was trying to run these things. So I did, little jump, and then tried to bigger and bigger jumps just to find a breaking point. I did try 1,000 threads. That was definitely a breaking point for both the systems, but I didn't bother recording them.
Okay.
All right. So this is all well and good. Little spot testing. Just it gives a good comparison of the two systems, but if you really want to know how things compare to each other as far as performance testing and be able to compare them, you really need to run something better than spot testing. So I'm a fan of benchmark.net. I use it personally and at work when I wanted to ask myself, what's going to be better? Is string concatenation better or is string interpolation better? I've done that at work and experimented with these kind of things. So I thought I'd do it here for the Raspberry Pi. I did it on 3 machines. This is my work machine. This is my personal laptop. My personal laptop that is, I don't know. It's probably 5-7 years old. And here's the Raspberry Pi. These are actually in order of most powerful to least powerful. As you note, I had dotnet 3 on all of them. I did have a little bit older version of dotnet SDK running on the Raspberry Pi. Personal one was running 201, same thing for the work one. Reasons for that is because it's much easier to get updates on my Windows and Ubuntu machines. It's here, this one is Ubuntu. So, like I mentioned earlier, string concatenation I had laying around from before, so I just reused it because it is something I actually asked myself a long time ago. What is better? Concatenation, string format, string interpolation, things like that. So not surprisingly, they are ranked in the same order that I had them on the previous screen. Lenovo, Samsung, and Pi. This is in order of performance, fastest to slowest. Actually, I was surprised to see there was a little bit of difference on the memory allocations. You can see here that 2-year-old laptop machine is performing fairly close to the personal laptop, which is, say, double the age. It does spread out as I put more extensive tests on it. So here is a string builder pattern where it concatenates, using string builder, concatenates 2 strings together using the string builder pattern API. And then here I'm saying it's actually 3. I know I've got 2 listed here, but you can imagine, a default string, and then I append 2 additional things onto it. And that's what these numbers meant, was there's something plus 1 value or 2 values to it, and then here we've got 3. There is an order of magnitude difference, but I expected something like this. This is quite surprising if you compare this against the Pi 3, which I did not record, but big jump in numbers as far as the performance of the Pi 4. If anybody's got any questions on that, we can dig into it. Otherwise, I will conserve time and move forward. Oh, Marty, you've got a question. Wondering if you can get better results if you run the Raspbian on a SSD. It would depend on your application. So right now, I've got 4 gig on here, and the applications I'm running should fit nicely in there. So htop. Let's see, the default memory usage with me remoting into it is 107. So when I was running the applications, I don't know what size it was, but they would have all been held in memory. So these small performance tests I was doing, I wouldn't expect any difference on the SSD. But if I was doing any operations that involved physical persistence, let's say I was running a database, MySQL, Mongo, or whatever, and I forced it to write out to the hard drives, then I would expect differences. Or if I'm reading from the file system to render static images and I was not caching them and things like that, I would expect differences too.
So maybe I missed it. How are you storing on the Raspberry Pi? Like, what is its storage mechanism?
The SD card.
Oh, right. Okay, gotcha.
Little micro. So just one of these little jubbies. Probably not showing well. Wrong way. There we go. So 64, and this one I'm holding in my hand, 32 gig over there. And then of course, like I said, the memory on this one that I purchased is 4 gig. So for my usage, quite a lot of space. All right, so that was one level of lower level performance. There's also, I took it another step. I did another series of tests saying how would it perform, it being the Pi versus the laptop, of having a string list of strings and searching for a particular instance within that list. Say it was 100 items in the list, 1,000, 5,000, 1 million. I wanted to do that to be a different kind of exercise. So the first one was concatenating. So it would have been more load on memory, because it would have been allocating over and over again memory, because string is immutable. So when you concatenate something, it's going to generate a new string, and do that over and over was the previous test. This one, I'm going to generate a list and then start running through the list. So the memory should have been fairly consistent in this other test I'm doing, but it's going to be more CPU intensive, because it's going to be doing comparisons of the values in there and crunching. I also decided to use, I did a hand-rolled version of Parallel for each, using weights and things like that. Just I had fun doing that. I spent like an hour on it just to see if I could do better than Parallel for each, and I was happy. No, I could not do better than the Microsoft engineers. Of course, they probably spent more time than me and probably had QA testing their stuff, but that was just fun. And just bring up that real quick. I do not have that in slide format. So give me just a second. while I bring up that location. There we go. Fastest find. Benchmark results. Let's go with 100. So the Lenovo, how did that perform? That's my work laptop, which is about 2 years old. Searching a list of 100. Let's just pick something out. In the middle, 42. It's 200 nanoseconds. That's what the find with for each loop. Let's go back here to the Pi. Put it side by side, and let me know if this resolution isn't good. GitHub results. We want what I say. Find with for each loop. Person's 42. Person's 42 for each loop. So here's the Pi. It was roughly 1,000 nanoseconds compared to 226 nanoseconds. So it is an order of magnitude, let's say, of 4-ish difference. I don't find that a bad thing. I find this actually quite good. You know, a $50 machine for this operation is performing 4 times slower than a, let's say it was a $2,000 laptop 2 years ago. Investment to performance, pretty good. Let's look at a million. How a million items did. GitHub. Make sure I clicked on the right one. Nope, I did not. 1 million for the Raspberry Pi. GitHub. So parallel for each loop, same thing. This is, let's go here. So this is a million items for each loop, finding the 666,000 item in the list for each loop. 660 right here. Parallel, wait, sorry, I got lost. Find with parallel 4, that's not the one, for each loop. That's the one I want. There it is. So the laptop, again, it's about 2 years old. That would be 8 million nanoseconds compared to 20 million nanoseconds. So times 2 is 16. Yeah, that's a difference of 2 to 3 times difference. So again, I'm quite pleased with this performance of a, what I say, $50, $60 little mini machine. Anybody have any questions, concerns? All right. So as I said, I was quite happy with the results. If we had time, we could go talk about some other things like installing Docker. That was actually a very easy thing to do. Like I said earlier, I was able to build on my Windows machine, publish for the Pi. I had to select Linux-ARM as what I was publishing to, otherwise I would get errors. I would also, if we had time, go into the Tech Empower benchmarks. That would have been a interesting performance test to get up and running. However, I will note that I can run it on my laptop, just a quick little test, which is, it's not a true performance test. It was just a, they have a command that you could run to just to make sure you have Docker and their code set up correctly. I was able to get that to run fine on my laptop and get 200,000 plain text renders in the time that it had. Meanwhile, the Pi, it would time out. I will note that if I had a proper setup, I could probably get it running just fine. Tech and Power, their testing framework, you need 3 machines to properly run it the way they want it. You need a client, a server, and the load generator, if I remember correctly. And then, like I mentioned, you can get VS Code running. I've got the link here to Scott Hanselman's instructions. I will wrap up here. Conserve time for question and answers. Anybody have any questions or things you want to dig into or tangents?
I don't have anything, but I was pretty impressed.
Okay. Yeah.
The speed
Again.
of that little thing.
Yeah. Again, $50, and it was not a slouch. I will say it is a big difference between the Pi 3 that I have. I've got a little Pi 3 for my kids, a little kit. There was a big jump in performance there. I did not record those things, but I was able to just take this SD card out of my Pi 4, put it in there, and run some quick tests and see some differences on the order of magnitude difference. So they did do good good large jumps, excuse my English, of going from the Pi 3 to Pi 4 as far as performance is concerned.
Yeah, that's awesome. Pi 3 is what I have, and that's a lot faster.
Yeah, and you can get it running. .NET can give you running on that too.
Excellent. Excellent. Thanks, David.
Welcome.
So you mentioned how much cheaper it is, right, to run on the Pi. So, but you're obviously also a hobbyist. So the question is, right, like if you weren't a hobbyist, if this wasn't an interest of yours, right, like would you still think that this would be the way to go to save money, or would it be like AWS Lambda or Azure Functions or something like that, or something else, you know,
So,
for kind of like a rarely hit website?
For a rarely hit website, I actually would go with the Pi, and the reason for that is I can guarantee that it won't cost me anything extra. If I properly configure Amazon to not charge me and not go over my allocations that I want, then yeah, I could be fairly safe. But I have made a mistake before on Amazon and charged $100 to my card by accident because I didn't restrict it properly. But meanwhile, the Pi, I know, spent $50, hook it up to my home network, and that's all it's ever going to charge me.
Gotcha. Okay, any other questions?
I'd like to thank everyone for their time. If there's nothing else, I will be sharing this presentation and the extra files I have on my GitHub account. I'll make it public, and I'll give that to Doug or Richard so they can publish it later on in this Meetup location like they have for others.
Yep, and we should have the recording for this as well, to published out to the site. So I guess, you know, that's basically it. A couple final announcements, I guess, or one final announcement. Well, two. So here's the first one. Expect to be doing this virtually again next month. So second Tuesday of every month, we meet, and it expected to be virtually for a while, but you know, I could be proven wrong, but that's our best guess right now. And the next topic next month is on the architecture conundrum, and that is by Orlando. And Orlando is a colleague of mine currently, and he also runs the Java Meetup here in Charlotte. And so looking forward to that talk, going over the various different architectural patterns and how, you know, it seems like, you know, everyone wants microservices, but is microservices always the right answer? Let's look at other architectural options.
Cool.
So thanks, everybody, and hope to see you next month.
Great. Thanks a lot.
All right. Bye.
Thank you.